Okay, welcome, dear students, to the lecture one, part three. So we're just going to get right into it. So I am doing this just for the sole purpose of not making the previous or making the whole lecture long, so you can watch them as you deem fit. So we're just going to go into it. So we're continuing with the ambiguity in significant figures. So this part will continue the ambiguity in significant figures, and ambiguity is a big word, but it's English language, so you can google it up and check. Oh, who knows what ambiguity is? You can tell it. Just think about it and say to yourself, what do you know what it is, or do you have an idea what it is? Then something is ambiguous. So it's something you say when something has more than one interpretation, so more than one meaning. Something's to, like, it can have different sides to it. So, and the ambiguity of significant figure is just the different faces that we can see significant figure, or what it can be. And it's all the same thing, but it can be viewed differently, and you'll see that from our explanation. So ambiguity will be clear to you. It's not going to be ambiguous to you. It should just have one fixed meaning and you understand it. So consider the measurement 500 grams. So if the measurement has been made to the nearest 1 gram, all the three different figures are significant. So obviously when you do the nearest 1 gram, so the way you can do that is, notice that it was made in the nearest 10, and then you have 2 digits, only 2 digits are significant. So you see the changes. So look at what we have down there in the next bit here, where we have 5.00. Notice that that's 1 gram, but when you put the thing we discussed previously, the exponential notation, you discover that it's 3 significant figures, and then times 10 to the power 2 now ensures that if you round them off to value, you still have 500 grams. And then the next one, the same thing as well. You have 5.0, excuse me, you have 5.0 times 10 to the power 2. When you round that off, when you take away the exponential notation, you'll still have 500. And then the last bit, which is 1 significant figure, as you can see there, times 10 to the power 2. Once you take away the notation, you still have 500. So notice that it is 500 grams, but we have interpreted it in 3 different ways. And that is what ambiguity really is. One thing, but it comes differently. It's like you see someone today here, same there, same person, you're like, it's everywhere, it's all over the place, and it's the same thing. So also with significant figures, they can be ambiguous because you can have them in different forms. 3 significant figures, 2 significant figures, 1 significant figure. So you can be asked to give something in 2 significant figures, 1 significant, 3 or 4, depending on what exactly it is that's going. So that's it in this. So we have now an example, and this example is straightforward. I'll just read it to you so that you understand it. There's a patient in the hospital that was given an antibiotic, which is what you give to somebody that probably has a bacterial infection or microbial infection, and is given through the veins intravenously. So the rate of infusion is set such that the patient receives 1.515 milligrams of the antibiotic per minute. So notice that you have the amount and the time, and this amount per minute is the rate. So how many milligrams of antibiotics are received after 35 minutes of infusion? So now the value that was given is the rate, and the rate is in amount per minute. And the word per, I think I said that previously. Percentage means, per means over, centage 100 relates to 100. So in this case, it means that you have 1.15 milligrams over the time. So, and if you are given the time, it means that you can find the amount somehow. I will not tell you how. I'll leave you to guess and try to solve it for yourself. So I like doing this, and this is going to be a habit through this video. Pause the video and find out how you can get the amount. Think about it. It's like a puzzle. It's like a game. How do I get the amount when I'm given the rate and given the time? And the rate is milligrams over minute. So how do I get milligrams alone without minutes attached to it? So that's what the question asks, and that's what you should solve. So try and pulse it. Make it a challenge, because it's going to be fun. It makes it more fun in that way, rather than me just getting straight into it. Why don't you try to think of how to solve it, because it helps your brain, and that's how you prepare for exams. So if you've tried it, good for you. Kudos to you. But if you didn't, I forgive you in advance for not doing so. So let's get right into it. So remember, I said rate is the amount I've infused over time. So if you have the rate, if you multiply the time by the rate, you'll have the amount here, because the time will cancel the time and then you have the amount. So that's how you go to solve it. So straightforward, you just multiply the 1.15 milligrams over minute by a minute, and these two units will cancel out, and what you have is 40.25 milligrams. And notice something: the significant figure is 3 for the rate and 2 for the time. So at the end of the day, your answer should be in 2, which is the list of significant figures, so it should be in 2. So 2 significant figure will be 4.0 times 10 to the power of 1, or 40, basically, straightforward, without the exponential notation. You just put 40 there. So that's it for this question, and I hope you tried it, because if you got the answer, another kudos to you. If you didn't, it's not an exam, so you didn't fail. So the rules for rounding off a measurement, we have certain rules. Every country, every sports has some certain rules you play by. If not, it's not a game if you don't have rules. So in this case, you have, like, if the digits are to be discarded less than 500, so it will be unchanged if it's less than 5. Like, notice here very closely, this is 23.315 grams, and this is 23.487 grams. When you're rounding this up to the nearest 23rd, it doesn't add up, because 3 is not up to half to be rounded up, 4 is not up to half to be rounded up, but 5 is up to half to be rounded up. That's why in the next part, you notice that once you have 23.679, you can round this off to 4, because this is over half and this is half exactly, so it can round off to 24. So that's the idea. The idea is that if something is half full, it can be regarded as full in a sense, but if it's below, it will just stay that way, because it's more, if you're talking about that degree of, it's more, it can lean towards 1 than less than 1. So you'll be more accurate if you lean towards 1 than less than 1 when it's around 5. You'll be less accurate if you lean towards 0 than 1. So it's kind of like the idea behind rounding off things. You don't round off something that is far away from 1 to the other. You can keep that at the behind. So you have the last one. I think there's a discrepancy here. Oh no, there is not. Corrected it. So 23.487 4 and 22. This can be 4, can be rounded up to 4. This can be rounded up to 5. So you can have that situation as such. And then the significant figure in addition and subtraction. When two numbers are added or subtracted, the significant figure is determined by the number of decimal places. So you determine the number of decimal places on the basis of addition or subtraction. So you round up and then you have a fewer numbers resulting in the same. So you have exact numbers, as the word implies. Exact number is specific. So certain numbers in calculation are exact and not approximate. So the value is exact. You don't approximate, because once you approximate them, you have error. Like 1.8 now in the temperature conversions, like Fahrenheit to Celsius or Celsius to Fahrenheit. If you do 2, you have a big error. If you do 1.7, you have a minimal error, but it's an error. So they are exact numbers. 32 exact, so you use them as that, so you don't round them off. So in some problems in the text, the numbers could be spelled out in words. So sometimes when you're solving a problem, you might have them say ONE gram. It's still 1 gram. It's just spelled out in word. So example, calculate the heat evolved when 1 kilogram ONE of carbon bonds. So you have to consider looking at it as exact 1. So consider number 1 gram to be exact. So this is what I was talking about earlier. And notice that when I teach, I say it before so that when you see it, it doesn't look strange to you. So I say conversion factor. I'd said it so many times before, but what it simply means is that factor that you use to convert something from one point to another. And this is where we see it, and it's not strange to you because I've been saying it. So sorry, my microphones went out, my earphones went out. So that's when I move my hands around a lot. So the approach is to use the conversion factor to set the units to another. Set one, change one unit to another. So the word conversion is to change, to convert, to invert. So you have dimensions of analysis. Let's go straight to it. So you have 1 liter, which is equal to 1,000 centimeter cube. Remember the previous time when we were looking at that was 1 liter, which is equals to centimeter, the milliliter and then centimeter cube thing. Remember when we're looking at the two variations and how they're very much the same thing. So 1 liter is equals to 1,000 centimeter cube, and 0.5 liter is equals to what? 500 centimeter cube. So notice that if you divide both sides by 100 centimeter cube, you will literally be having 1 as your constant or your factor between them, because actually 1 liter is 1,000 centimeter cube. So if you divide both all through by that, this will cancel this, and this, which is invariably equal to this, will cancel out, and then you have 1. So that's what basically happened. 1 divided by this will be 1, to be this, and then you have 1. So that's your factor for it, 1. So how it works is that once you have a fraction with your numerator, which is the one above, and the denominator, which is the one beneath, you will always have to put what is wanted as the numerator and what you want to cancel out as the denominator, so that once you multiply through, this will cancel this and your wanted unit is going to be there. So most of the times you have to switch them up and then cancel out. Initial units are cancelled because they're underneath. The final units are above. They stay that way because of how the concept of multiplying through fraction works. So we have relationship between length, volume, and mass, because we looked at them. Length, volume, mass, and then we had temperature. But temperature is just one of those things that stays on its own. It's only a factor that relates with other ones, but we just have the table containing the relationship between them. And you have your length. There's a whole lot of that's 1 kilometer. You have the centimeter, you have all of this. It's quite, just go through them randomly and just go through all of them. So it's just a metric system. Then we have an example here, and this is a very good example that I'd like you to pause the video to attempt. Okay, before you pause the video, let me read through it so I help you understand the question, because I feel some people need some help. So a red blood cell has a diameter of 7.5 microliter. The red blood cell is basically a component of your blood. That's a component of your blood. Your blood has your plasma and the red blood cells, the white blood cells. The plasma contains the white blood cells. The red blood cells are the thing that goes down when you separate your blood or you centrifuge your blood. So, and the red blood cells are the ones that carry a lot of things and such. So they are spherical in nature. They're round. They're almost like your, I don't know, capsules. Those round kind of, like, that's what they look like, but they're red in color. So, and they have a diameter. It means that if something is round, let's say it's my hand, my hand like this. If something is round, it has a diameter of, like, the diameter is that there's the radius, which is half from the center to the end, and then diameter is the full length. So it has a diameter of 7.5 microliter. Micro there, you know what micro is. If you're forgotten, you can go backwards and check. And what is the diameter of the cell in inches? So it simply wants you to convert the microliter to inches, and it helped you out with some conversion factor there. So inches to centimeter, but you have it in micrometer, so you have to work it backwards. So that's it. So pause the video now and try to work it backwards, given the information there. So you have it 7.5. This is the conversion. So the relationship between micrometers and centimeter is what you should work with, and then you convert it from there to centimeter, from centimeter to inches. So you can do it. I believe you can do it. Just go for it. Some of you are still looking at me. Take your paper and start solving. Okay, that's good. Some people have gone for it. Some people are still looking at me. So let's just continue. So let's go into it. So what you have is from micrometer to centimeter to inches. So you use the conversion. So remember, we said for micro is 10 to the power of -6. So and you have 7.15. So remember, we said to cancel out, you have to take the other one on down and the thing you want on top. So look at how it's done. You cancel this, and then you have this multiplied through to this, and then you have a value that's a meter. So down with that value, 100 centimeter is now the 1 meter. This is actually the conversion situation going on. So once you do that, this will cancel this, and then you have centimeter, and the last bit is your 1 inches over the centimeter. So this now will cancel this. So basically what you have going on here is the initials are canceling the initials and just going here till you are left with inches, and then that's what your answer is going to be. So there are two ways to do this. You can just simply say the usual 1 microliter is equal to 1 times 10 to the power of -6 meter, and then 7.5 microliter is equal to x, and then you cross multiply, and then you find one, you do it again, or you just do it straightforward, and then you have your answer. So you can do it the hard way or the easy way. So that's it. Have another exercise again. So now let me just read it through, and then you try again, and notice that the more you try these exercises, the more confident you will get in your ability to think and try to solve a problem, because that's the goal of study. You need to study and learn and be confident in what you do. And going through the university helps you to do that, because you write a lot of exams, and over time you're like, if I can do this, I can conquer the world. So you have the bed in your dorm. If you stay in the dorm, if you're outside the dorm, the bed in your house has an extra long mattress or mattresses, and this mattress 80-inch, has two significant figures long, and 39 inches wide. So 80-inch long as the length, and then 39-inch wide as the width. And they said the regular twin beds are 72 inches long. Basically, it just gives you an idea of what the regular is, but the one there is 80, the other width is 39. So they say, what is the area of the mattress top in meter square? So now they want you to find the area, and area is in meter square, but you are given the values in inches. So you're going to work from inches to meter, so inches to centimeter, from centimeter to meter. So that's basically how you're going to solve this. So go for it. I'm begging you, go for it. You can do it. It's not too complicated. You can do them individually and multiply them, or you can do them together, but be careful when you do them together though. Some of you are still looking at me, or you're waiting, you're just skipping through. Okay, let's just go. So what you have here is what I said earlier, area is equals to length times width, and that's your area. And then you notice that they're squares, so if you multiply them through, you better be careful when you're converting, because you have to square it as well through. So you have them, you multiply them through, so notice the squares and the powers. So once you multiply that, you have inches square, and then you have the whole power. And then when you go through it, notice that from inches to centimeter, you put that because that's what's needed above, and then the 1 square as well, because even though it gives you the same 1, you just square it for square sake. So you multiply that through, and here you square as well, and then you multiply that as well. So you have to square it all through so that you don't make a mistake. So if you're doing them individually, it's more complicated, but you're more sure of your answer, but if you square this, you're sure as well, but ensure you don't make the mistake to forget to square. So you square the conversion factors as well. So at the end of the day, you have 2.0 meters square. So that's as that. So at the end of the day, the end point is that there are 36 inches in 1 yard, and the dimension of the mattress is approximately 1 yard wide and 2 yard. It's almost half, because it's 80 and 39, so it's half. Is 1, and then the other one is times 2, so it's 80 and 39 is almost 40, so it's 1, and then the other is 2, or 1.5. So I mean, when I mean 1, I mean the length is 1, and then the width is half, or the width is 1, and the width and the length is 2. So depends on, it's 1 to 2. So that's ratios. So the meter is most equivalent to the yard calculated using a small ballpark. So I think we'll stop here, and then we'll continue. I think that works. So the video is not going to be in 4 parts, and then the 4th part is the last part. So we're going to be looking at properties of substances, and that is the last part of the video. And please do well to check up on. You can watch the video several times. They're short, so I made it short for the reason that you can, any part you like or you don't get, you can just watch it over again. At least try and watch it, because you're in your house, you're inconvenient, and it will help you in the exams that we're going to be doing. Please try and engage yourself in the course, and don't be lazy, and don't give in to laziness, because at the end of the day, you're going to graduate, and you need to have something in the head that confirms that you actually went through the university system. So that's my little encouragement. So try your best. It might be hard now, but it'll be easy later. So just give it your best and you will not be disappointed. Work doesn't kill you, it makes you stronger. Thank you. See you on the next one.